So that is why we're here today, kind of to talk about how we can do more with less. Not less with more, more with less. I guess I should say just a couple of caveats. I have two talks here today. One is kind of the tried and true, here's how to get started with Spring Cloud Stream and use the existing state. This is the all kind of new looking forward. So this is kind of reaching out ahead into the future just a little bit. So this may look a little different than what you're used to if you have worked with Stream before. But that's okay, just sit down and buckle up, and I tend to narrate extensively as I go through things in code anyway. So what kind of takeaways are we looking at today for this particular session? We're going to talk about message brokers and streaming platforms a bit, talk about Spring Cloud Stream, why even use it, right? What does it bring to the table? What are reactive streams and Project Reactor? How do they fit into the mix? And then how to bring it all together for kind of crazy, ridiculous scalability, and then turning it up to 11, which we'll get into here momentarily. So who am I? What makes me semi-qualified to talk about this kind of stuff? I have co-authored a couple of books. I've contributed content and code to several other books, some of which actually even recognize me. That was nice. But all of the stuff I do, I pretty much throw out open source anyway, so it's all good. I am an architect and developer, and as you might surmise from the next point, where most of my expertise has been it's been in the area of Java, working with Java for several years now. It's not a monogamous relationship with the Java language. I do dabble in Kotlin. Shh, don't tell anyone. I actually love Kotlin quite a bit, so I find that when I hop back and forth, they're such complementary languages that the biggest thing that I always forget is the semicolons. Go figure. But I am a professional problem solver, as I like to call it, and I am a Spring developer and advocate with Pivotal. So with that out of the way, let's go back to our takeaways and kind of work through things. So here are the big things, right? I took some notes because, again, I'm debuting two brand new talks here, and I want to make sure I don't leave out any of the best stuff. So I'm going to kind of make sure I stay on target here. So in the interest of time, I'm going to make some very necessary assumptions. If you don't understand anything, though, that I lay out, please see me afterward, because I do kind of have a method in my madness, and I'll happily explain whatever you may have questions about that maybe I kind of glossed over a bit too briefly. For starters, I'm going to assume that you understand the benefits of moving, at least to some extent, from a monolithic architecture to a microservices-based architecture. Even if you maintain some monoliths within your organization, which is legit, right? There are valid reasons to do so. You're still going to be communicating between those monoliths and external services and systems. It's just kind of the nature of the beast. And either way, whatever happens is that you're often using a REST API to do that. REST APIs have numerous benefits as well. And I suspect many of you can point out several of those too. Most of us probably know about Jeff Bezos' infamous memo in which he detailed that all Amazon functionality should be exposed as services and only accessible via interfaces, right? Via APIs. In effect, creating microservices before microservices were cool. And even though he didn't specify REST in terms of an API mechanism at the time, it certainly became a large beneficiary of that, shall we say. We're also probably all familiar at some degree with the 12-Factor Manifesto and its various permutations. If not, again, please see me afterward. Happy to discuss this at length. Perfectly happy to do that. The upshot, though, is that REST APIs have enjoyed extensive use in connecting various systems, right? And for the most part, they do work, and they work well. But there are several issues with using them for all inter-service communication. Performance and scalability among are two. They're limited. Both services must be online and accessible at the same time, right? Sufficient numbers of instances must be available, again, simultaneously to meet the traffic spikes and surges. And the network connection must be sufficient and must be stable and sufficiently performant at all times throughout all of the associated request-response exchanges. And we haven't even covered what really happens when failures inevitably occur, right? When the network drops out, when an instance of one or the other crashes. We see that there are many choke points and weak links when it comes to inter-process communication via REST APIs. So messaging platforms reduce or eliminate these concerns in various ways. I'm still feeling like this is a little hot. I think maybe it's sliding back. Message platforms benefit from being a part of your critical infrastructure, which typically means that your cloud provider or your critical infrastructure team maintains those and makes sure they're online and accessible at all times, right? So that's very important. They typically also come with fully configurable delivery guarantees, retention, and what have you. And it also, which provides you with a way to verify that each message is verifiably delivered. It also allows you to separate your producers and your consumers both temporally, because your consumers don't necessarily need to be online when a message is produced by the producer, right? And locationally, because the consumer doesn't necessarily need to know or care where that message came from, only that there's a message. So that helps considerably, because then if something does happen to fall out, if some instance of your consumers does crash, then when that comes back online, that message is there and ready to be consumed. In short, anytime you need greater performance and scalability, reliability and resilience in inter-service communication, a messaging platform is probably a really good starting point. So there are many options in messaging, but the big ones are RabbitMQ, Kafka, Amazon Kinesis, Microsoft Event Hubs, and Google Cloud Pub Sub, right? Excuse me. And those are the big ones, but even the ones that I just mentioned, other than RabbitMQ and Kafka, actually typically expose AQMP, Advanced Message Queuing Protocol, which is kind of the Rabbit default protocol, as well as Kafka APIs. So those are the two that everything kind of comes back to almost inevitably, right? So why Spring Cloud Stream? What is Spring Cloud Stream and why use it? Well, as you might imagine, one size doesn't fit all. Your company may have standardized on RabbitMQ, maybe it's standardized on Kafka, maybe it's using both. Maybe it's using Kafka and your company acquired another company that is standardized on RabbitMQ. This happens all the time. So if only there were some way that you could abstract above that and not get into the weeds, where you could focus on the business logic, on what you need to happen and how, and not necessarily on what the underlying plumbing is. Well, there is, actually. Spring Cloud Stream provides a powerful, opinionated, but extensible abstraction for messaging platforms. So you can write your code to be independent of who lays the pipes underneath. Binders make all of this possible as you add a binder library that supports your underlying messaging platform, right? And you provide any required or desired configuration, and Bob's your uncle, you're up and running. So that allows you to focus on what's truly important, your business logic, right? Versus learning about all the intricacies of Kafka replication, for instance. Spring Cloud Stream is based on Spring Integration and Spring Boot. Spring Integration provides its hooks among the various different components. Very nice wiring, if you will, underneath the surface. And Spring Boot provides its auto configuration, ease of deployment, and let's see, I'm just completely going blank here. And Dependency Management, of course, which is the other thing. So it allows you, again, to elevate your focus and to focus on what is important in terms of what you're wanting to provide business logic-wise. So Spring Cloud Stream provides does a lot of the heavy lifting for you while still giving you access underneath to what's underneath and allowing you to tweak where you should so choose or need to. Let's say your CTO reads a tech magazine, The Horrors, right? Is anyone familiar with the old Dilbert comic strip where they spot somebody, a manager with a magazine, and they hit them with a sleep tranquilizer dart so that they can take the magazine and save the day? It's kind of like that, right? So if your CTO reads a magazine and says, we should be using Kafka, and you've standardized on Rabbit for the last 5 years, what do? Well, if you write your code right, you can actually just do a rebuild and rerun it, and everything just magically goes to Kafka. Or if you've foreseen this particular instance, and you've written your code right, you've got your configuration in place, you can actually do that dynamically. Probably not a huge demand for that, but it's really nice to have the power to do it, right? So let's take it from there and let's dive in a little bit into the Reactive Streams and Project Reactor side, because that kind of covers the messaging platforms and Spring Cloud Stream and what that brings to the mix. So at this point, I need to back up just a little bit and talk about about the typical way that Java applications will scale, right? Java scaling has been very consistent and understandable for a number of years. With imperative Java programming, typically the way you scale is that when you have additional connections come in, additional requests, you spin up another thread. And that's very easy to reason about, right? Because with each additional connection comes an additional thread until what? Thread exhaustion. Well, actually, let me back up a step from there. So let's say you have 100 threads running, right? What are they doing at any given point in time? Nothing. They're blocking. They're waiting for a response from another service or a database call or a file system call, right? So it's easier to reason about, but it's not terribly efficient. So I like this quote by Rossen Stoyanchev, one of our Project Reactor team members, who kind of summarizes the advantages that reactive programming in lieu of imperative programming bring to the mix. In a nutshell, reactive programming is about non-blocking event-driven applications that scale with a small number of threads, with back pressure as a key ingredient that aims to ensure producers do not overwhelm consumers. Now that packs a lot of meaning in one sentence, which is why I like it, but let's unpack it a bit. I've already mentioned kind of the frustration with imperative programming, and I should say that if you're looking at performance gain, sometimes people will ask me, what kind of performance gain will I see if I go to a reactive programming model? Probably the wrong question to ask, right? Because in and of itself, you don't gain performance. What you do gain is scalability. Because if you're talking about raw performance, let's take this all the way down to one connection. If you have a single request coming in, and you're blocking and you're waiting for the response, as soon as that service has a response, it hands it back. You can't get any faster than that. You have a dedicated line. There's nobody else competing for resources. But when you start scaling up, or scaling out, I should say, and you have 100 or 500 or 1,000 requests, that's where you start getting that creeping up in terms of response time until you hit that hockey stick, right? When you exceed the number of threads that you're capable of providing, that n+1 thread has to do what? It has to wait for a thread to be freed up. So that's when that performance, well, I should say from your perspective, it goes here and then it starts creeping up and then it just hockey sticks up. What you gain with a reactive programming model is you get a very flat linear scaling profile. Because by inserting an event loop into things, what you actually do is add just a slight amount of overhead. So on that one connection, it may be just a couple milliseconds slower. But it keeps that very flat performance profile across a crazy, crazy number of requests, which is great, right? We don't want to, though, however, just use one thread. I mean, we've seen what that can do with Node, good and bad, right? Because it can provide a great amount of throughput. But of course, one bad actor can upset the apple cart. So what we want to do, ideally, is have a small number of threads that's automatically managed for you. Now, you can tweak that. You have full power over it. But in most cases, you don't have to. The scheduler just handles that for you, which is really nice. And it also keeps things, let's say a blocking request, from gumming up the rest of the works. Back pressure, that's kind of a key part, right? Sometimes people look at this and they say, this sounds a lot like asynchronous programming. Anyone done asynchronous programming? That's a lot of fun, right? Yeah, everybody laughs. Oh dear. There's a term you may have heard of called callback hell. And I'm here to tell you that's an optimist term. Because there are two things that asynchronous programming give you, or that don't give you, I should say. One is readability, because what typically happens is with callback hell, you have this string of nested callbacks. When this completes, call this. When this completes, do that. And and then you say, well, when that one completes, do this, and that one does this. And it makes for very illegible code. What we want to do is have a more declarative syntax that we can actually read, understand quickly, and grok and move on. We also, with asynchronous programming, don't have what? We don't have a way for slower consumers to push back. What happens if you have a very prolific producer producing 1,000 values per second, and you have a slow subscriber, a slow consumer, which can only handle 10 per second? I mean, typically what happens is that slow consumer is just overwhelmed, right? It falls over. It dies. That's sad. In reactive programming, you have a way for a slow consumer to say, look, I can only handle 10 values at a time. Just give me 10. That's it. And when I'm ready for the next 10, I'll let you know. Or 50 or 100 or what have you. And what that gives you is it doesn't change the fact you have a very prolific producer. But what it does change is it puts the controls for how to deal with that back into the service, back into our hands, right? We have a lot more control over the cloud service we're writing versus an iPhone client 3 countries over. So this gives us more tools at our disposal to manage that. Okay, so with that, let's go ahead and advance here and go back and let's see. Oh, Spring Cloud Stream and Reactor. How do we bring this together? Well, I'll show you kind of how we're bringing this together. And this is kind of the exciting part. Because simply using the messaging and streaming platforms really helps the scaling a lot, obviously. Provides a robust and reliable architecture with delivery guarantees, what have you. I kind of covered that. But there are, of course, potential choke points we want to avoid. Reactive Streams-based microservices extract more work from fewer resources and allows you to handle more clients as well. Now, this is, again, very much a work in progress. I'll show you the kind of the current state and where we are headed looking forward. So there are a few rough edges. This is going to be so exciting. I hope it all works. Okay, so, so let's code. What could go wrong? I do have to say, for those of you, if you're not already following me on Twitter, why not? I guess that's the first question. MKHack. Twitter is the best way to reach me. I live on that. I only check email sporadically, so if you have any questions, comments, or feedback, that's the best way to reach me. But if you haven't been following me on Twitter, you probably don't know the drama with this little thing. This is a fairly new machine, and it's like randomly, sporadically crashing on me. So hopefully, we'll get through this today. We'll see. That's the tire fire, right? Okay, so let's stop there. Okay, so does anyone recognize this? Yes, okay, a few people. That's good. This is all new. Just kidding. This is the Spring Initializer. This is your starting point for Spring Boot-based microservices on the web. You don't have to go here to create Spring Boot-based microservices, but I like to because it's just kind of a nice jumping off point. And if you'll pardon me, I'm already getting animated and hot here, so I'm going to strip. I promise this is as far as it'll go, so no one flee the room screaming. Okay, so there we go. Now, whew, all right, let's do this. Okay, so what I'm going to do is start off and just kind of go with this opinionated approach. The Spring Initializer is just like all of Spring. It has an opinionated approach that gets you started quickly. If you want to color outside those lines, that's great. This is not like the bad old days of frameworks where you literally had one way to do anything, and that was the framework way. If you fought that, you lost. But this opinionated approach gets you up and running very quickly, right? And if you need to tweak things, you still can. So even with that, you have some choices to get started quickly. Now, I should say that this generates your project for you. It doesn't really generate code. It will create your main application class and your main method. That's it. But it gets you started quickly with that Spring Boot dependency management, your starter bombs and things like that. But it gives you choices even there. So if you're a Maven developer, you can create a Maven project. If you're a hipster, you can create a Gradle project. Now, I kind of go back and forth on this, right? You know, some days I'm feeling more hipster than others. I just lost my hoodie, so I think I'll stay with Maven. But we'll stay with Maven and Java another time, maybe for Gradle and Kotlin. I'm going to go all the way up here to the brand new snapshots, right? 2.2.0. So this is we're out on that leading edge here. What could go wrong? So I'm going to change this to the Hecklers. Won't work otherwise. Just kidding. So we're going to create, and I should say that, oh gosh, I kind of skipped blithely over a couple points. With Spring Cloud Stream, there are a couple of interfaces, well, 3 interfaces built in for you for ease of use and consumption. One is the source, so that's the thing that produces values that then dump into a pipeline. One is the sink, which catches those values at the other end and does something with them. And then there's a processor, which actually incorporates both. So it will catch values, manipulate them, and then pass them on. Similar thing with Reactive Streams, and Project Reactor is built around Reactive Streams. The Reactive Streams initiative was created by several companies and organizations who came together to actually cooperate, which is a really nice change, right? Because every time companies can create competing designs that don't cooperate, that don't interoperate, who gets caught in the middle? We do, right? We're the developers who write the nasty glue code that make one thing work and pass on to the other, which is terrible. So several companies got together and they said, look, let's make this all work together. Twitter, Kazing, Netflix, Pivotal, Red Hat, Lightbend, probably another one or two that I'm forgetting. But they said, look, we may all have different ways of implementing this, but they should work together, right? Project Reactor is our entry that we fielded. And of course, we do cooperate well. We get along with the Akka folks, Akka Streams folks. Actually, one of our big committers is David Karnock, who leads the RxJava 2 project. So it's all a pretty good bunch, right? Which is nice. But the Reactive Stream specification defines 4 interfaces. Excuse me. One is the publisher, which creates things. It produces things of, let's say, type T. One is the subscriber, which catches those things and absorbs those, similar to the source and the sink, right, in streams. So you can see how this would be a natural fit. One is the subscription, which is the contract entered into between the subscriber and the publisher. And then you have a processor. Sound familiar? Which also, again, takes values, manipulates them, passes them on. And again, these are interfaces. So you need to provide or use an implementation of such. You can write your own, but it's not for the faint of heart. There's a lot of stuff involved in that to do it right and to do it well. So Reactor provides that well-tested, well-proven option. Now, Spring Framework 5, Spring Boot 2, is built on Reactor. This is one of the first external dependencies we've ever had. And it is external. You can use Reactor with any Java application. You can even use it on Android, should you wish. But this is part of Spring Framework, and it's built into the packaging that is now referred to as Spring Web Flux. Now, Spring MVC is still there. It's not going anywhere. It's used to run thousands, maybe hundreds of thousands of production applications around the world, right? It's not going anywhere. But what we did was we created parallel packaging, so Spring Web MVC and Spring Web Flux. Flux being a specialization of the publisher interface in Reactive Streams. So in standard imperative Java, let's say when you have a method, you can return an object of type T, right? Or maybe an iterable of type T, so some kind of collection. And the same thing kind of goes with publishers. It kind of makes sense in some ways to specialize between I want to return a thing or I want to return a bunch of things. So we specialize publishers into mono, which means you'll get 0 or 1 response, 0 or 1 value, or a flux, which can return maybe a small collection of values, or maybe an indefinite number of values over an indeterminate amount of time. So you'll see those pop up from time to time. Some operations apply equally well to both, some don't, so it made sense to specialize. Thus the term web flux, right? Because it's based around the name flux. Yeah, I know, I didn't come up with it. I didn't even vote for it, but it's all right. I like it now. So, so let's start off and let's code a few things here, because I always think it makes more sense to see it when you're writing the code. So I'm going to create a reactive source application. If I can type here, typing's hard. So we're going to choose a few dependencies. I'm going to bring in the reactive web dependency, and that gets me Spring Web Flux, as I mentioned, which gets our reactive bits, and Netty. Now, if for those of you who've done Spring MVC development, you know that it defaults to what? Tomcat for our servlet engine. But you can replace that. You can swap that out. Same thing here for our reactive engine. We actually use Netty as the default, but any servlet 3.1 compatible engine, so things like Tomcat 8, Tomcat 8.1, Undertow, Jetty, perfectly fine, but Netty is well tested and well proven, so we'll stay with that. Let's see, I also want to bring in my Reactive Cloud Stream capabilities, so that gets us Spring Cloud Stream with the reactive bits as well. I'm going to use Lombok just to make my life easier because I'm a lazy developer. Lazy good, not lazy bad, I just want to clarify that. And then of course, since we have Stream, we need to provide a binder, and I kind of mentioned that earlier. That's what we're going to, that provides the interactions with our underlying messaging platform. So let's see, I'm going to bring in Rabbit here, Rabbit, if I can spell right. Again, spelling's hard. I'm counting on you in the front row to catch my spelling mistakes before I hit build. I hope you knew what you were signing up for. If not, well, it's too late to run now. So, all right, so let's generate the project here. So let's just dump that out on the desktop. Here, desktop, there we go. Okay, so let's open up that. We'll unzip the project, and we'll open that up in our favorite IDE, NetBeans. Just kidding. Any NetBeans users? I like NetBeans. I like to pick on NetBeans. I like NetBeans. NetBeans is an awesome IDE, and it has great Spring support. Any Eclipse users? Really? Wow. Okay, no, I'm kidding. Eclipse is awesome too. We actually have a build of Eclipse called Spring Tool Suite, which works a treat. We have folks working on that all the time to actually have some really great cloud deployment capabilities built in. Every time I see them and they improve them again, I kind of wistfully look at them. But IntelliJ fits me best, so it's just what I go with. So let's see. Oh, shoot. I should have changed this. I am so sorry. Let's see. So theme. I always like to go with the high contrast theme. I think that actually it makes you want to poke your eyes out when you're normally working on it. But in presentations, I think it works really nicely. So let's see. Let's do. Look at that. Oh, that's pretty. Okay, so let's go first to our POM again because we're living on the edge, and even choosing the 2.2.0 build snapshot doesn't get us far enough on the edge. So let's take that just a step further here. I'm going to provide a specific version here, and then I'm also going to bring that up to my rabbit binder. And then again, just for good measure, because we aren't out there enough on the edge as it is, I'm going to now bring in a couple more dependencies here. And this will be our Spring Cloud Stream non-reactive stuff, and then also our rabbit core. Now this will change, obviously, with the next release candidate. Some of this extra setup will go away, but for right now, this is the price of being right out on that bleeding edge. So in our application.properties, I need to provide a few basic default properties that help us keep things straight. I'm going to just set the server port equals 0. That way it'll assign a random port, and we can eliminate or avoid port conflicts. And then I'm going to provide my, up arrow, no, down arrow, there we go. So my bindings. Now this will be my source. This is our source of producing values, right? So we're going to have an output. And as I mentioned earlier, we have a source, a processor, and a sink interface built into Spring Cloud Stream just by default, which gets the job done 90-some% of the time really well. I'm going to bind this to an output channel, right? And we'll provide our destination. I'm just going to call this my processor channel. Processor. Spelling, again, is hard. And I'm going to assign this also to my group. And that gets us, I think, everything that I need. We can also specify our content type, but it defaults to JSON anyway, so that's fine. So let's go here to our main application class. And there we go. And actually, we don't really need to do anything here, so I'm going to have to take this back to... Can I do this from here? Oh, look at that, I can. How nice. So I'm going to create a few classes that I need to support our particular use case. One is a subscriber class. Now, you always kind of struggle as a presenter with coming up with something that is a fairly common use case that everybody can kind of go, yep, that kind of looks like what I'm doing at work. So we're going to assume that we have a subscription-based service here that we want to keep track of new subscribers. Wow, we're going to have to speed this up. Okay, that's exciting. So I'm going to use Lombok, and I'm going to annotate this with @value, and that gets us some things for free. Our allers constructor, our getters and setters, equals hashcode toString and all that. So what kind of properties do we need? Well, we'll have some strings like ID, first name and last name, and then we also will need some kind of a timestamp, right? So subscribe date. So that's good. So let's go back over here, and we will create a subscriber generator, because again, this is our source. We're going to be passing these subscriber details down the stream. So we'll create a subscriber generator. Okay, that's easy. Component. Wow. This is tougher than it should be. Okay, so I'm going to create a few things that will help us get this generated quickly. So I'm going to create a string array of first names. First names equals. So let's see. I fly a lot, so I'm going to use the aviation phonetic alphabet, and we'll just mix and match these. So Alpha, Bravo, Charlie, Delta, Echo, Foxtrot, Golf, and hotel. This will make some fun first names, right? And we'll just split these by comma, semicolon, and that's good. And actually, let's just duplicate that and make those last names too. I need to create a random, so new random object, boom, boom. No. Oh, Yeah. I told you, going back and forth with Kotlin sometimes catches me off guard. So int, I, and j. Those of you who code in Kotlin are going, yeah, I live that dream too. So let's see. We need to provide a generator method. We're going to provide subscriber. So generate. And what do? We'll do a return new subscriber. We'll use a UUID toString for our ID. And then we'll take our first names, and we'll say I, right? Actually, I need to do something here first, because of course I need to do I equals random dot nextInt, and what do we have? 8, right? So immediately type 9. Great. Okay, and then we'll take this and make our j the same thing. And we have first names I, last names j, which gets us a good mix. And then instant.now, so we get our timestamp. So that looks pretty good for our generator. Let's go back over here, and let's create our sender, right? So let's do this, Java class, and we're going to create some serious spam here, so we'll just call this spammer. Why not? So now I'm going to make this component. Actually, I need to enable my binding, right, to my source dot class. So this will bind us to our source for Spring Cloud Stream. And then I'm going to inject our subscriber generator, and we'll inject that via constructor injection, so that handles that nicely. And then I need to, let's see, what I need to do here, I need to create my stream emitter and assign this to my output channel. So source.output, and then let's just kick off this. So now we do a, let's see, we should just be able to do return a flux of subscribers, right? So that gets us our publisher. So send. Let's send those. So now we just do a return flux dot, and I'm going to create an interval here, which is just a pulse. And I'm going to get a pulse. Actually, let's do, that's fine. 1 per second is fine. Now, we don't need to worry about this necessarily with back pressure, because we know we're going to be producing 1 per second. Surely every sync and processor can handle 1 per second. But as a good practice, you should always define what happens on back pressure, right? So if you have a slower subscriber, what happens to those values that you're producing in between the times that it requests values? So I'm just going to say drop any of those values. 1, because we know we're not going to have to drop any. 2, because we only are concerned about what's happening now, not what happened 3 minutes ago, right? But you can define buffers and size of buffers and all that should you want to. And I'm going to map each of those values. Man, I just keep mistyping here. And we're going to create a new, we'll just do our generator, right? .generate. And that should be good. So now that we're set on our source, let's go ahead and create a processor. And 10 minutes, tons of time. So we'll create a processor and a sync. So let's go back here, and we'll create our processor and generate that. We'll save that, and let's go ahead and do our sync, and we'll save that as well. Yes. Don't you just feel it? So let's see. There we go. So now I go to my processor. I unzip that. Come on. There we go. POM open. Oh, and this is the quirk with IntelliJ. It doesn't like it when you have multiple projects open when you're in presentation mode. So first thing we do, once again, is go to our POM. Again, we'll just lift these couple dependencies, and we'll duplicate those. And, oops, I should have done my version, shouldn't I? Let's see, version, and 2.2.build snapshot. That's cool. We'll just copy that. And, of course, this is our stream. We'll do this in one shot. And our binder, core. There we go, core. That's fine. And paste here. And paste here. Okay, now let's go to our application.properties. Now this gets a little more complex, right? This is our processor. So again, we'll just set our server port equals 0, but now we need to provide our bindings. We have inputs now because it's a processor, so we'll do our destination, and this is pulling from the processor input. And then we will also do our group. And then let's just duplicate these, right? And we cancel. And we have sync here for our output. And we'll also feed our output group. Output, helps if you finish it. There we go. Also to sync. Now, here's where it gets really cool. I'll come back to this in a moment. But we have a function definition. This is kind of that forward-looking part. We'll come back in a moment to that. So let's go first, and we'll quickly define our classes here. So new Java class, subscriber, once again, at value, and again, private string ID, first name, last name, private instant, subscribe date. And then we go back over and let's create our message endpoint. Message endpoint, and here we'll enable binding to our processor. Correct processor class. There we go. Okay. So here is where it starts to get really kind of cool, because what I'm going to do is just define a bean here, and we're going to define a function, and it's just a standard Java function, right? But we're going to take a subscriber, and we're going to create and pass on a subscriber here, and we'll just we'll make this uppercase. We're going to do a very simple example. We're just going to uppercase it, and actually I'm going to make uppercase it. Yes, I like that. So we're going to uppercase what we get in. So very simply, we're just going to provide a lambda. So we'll take our subscriber, and we'll do a actually new subscriber s.getID, right? s.getFirstName.to uppercase, s.getLastName.to uppercase, s.getSubscribeDate. Pretty simple, right? So then we can just go back here. Oh, I actually can't do that way. So I'll go back to my application properties, and we'll say uppercase it. And that's literally all it takes, which is really cool. But there's more. Let's see. So message endpoint. So we'll come back to that in a moment once we've created our sync. So let's we open up our sync project. And then I am just out of speed here. So we'll go to our POM, and here we actually only need to copy our rabbit binder here. So version 2.2.0 build snapshot. There we go. And we need to make this core as well. So we bring in our core, and then we need to do a version here, 2.2.0 build snapshot. Grab our application properties. Come on, IntelliJ, keep up. There we go. Server.port 0, spring.cloud, stream, bindings, input. This is our sync, right? So we have our input destination equals sync, which is a channel that I have defined, and then we'll copy that and have our group as well, group. Okay, so that's good. So let's go back here. Oops. There we go, much better. New. What did I just do here? Oh, good. Okay, I'm going a little faster than maybe I should. So subscriber at value, private string ID, first name, last name, private instant. Yes, that's fine. Subscribe date. Okay, back over here. There we go. Come on, machine. All right, and now let's create our endpoint here. Message endpoint. Now, here we need to add enable binding to our sync, right? Dot class. All right. Nope. There we go. And let's create a bean here, and we need to make this a consumer of Flux subscriber. And there we go. Yeah, that's fine. What's the deal? Okay, so now we'll just log it. We'll log it, and let's just take our subscriber and do a subscriber. Let's see. What am I missing here? Yeah, but I mean, it should be coming through. Consumer, I love it when stuff goes wrong. Oh, God, yeah, this is a, yeah, I'm fine. What's wrong here? So subscriber flux. This is what happens when you do try to rush too much, right? So system, come on, get back here, IntelliJ. System dot out print line. Yeah, it's amazing how right stuff looks when it's wrong when you're going too fast. Okay, so we have that, but now we need to register. So here we go to our application properties, and now we once again provide our function definition here, log it. So that's all you have to do. So let's go ahead and start this, and then there's an extra little cool trick I can show you which really puts the icing on the cake, assuming all this works, of course. Okay, so we're up and running, so that's a good start. So now let's go here, and that is our source. So I need to go back to my, boy, hold on. There we go, there's our processor, so let's run our processor. Make sure I haven't missed anything there. Oh, happy day. Okay, so let's go back to our source. And then while that's coming up, we'll go back to our processor. And we should start seeing some values just trickle across here. Look at that. And we're uppercasing it. So that's working. So let's go back to our subscriber. Boy, why is that just not... that's our source. Come on, IntelliJ. So go out of full screen presentation mode, and let's go back to our sync. And the sync's working fine. 1 minute. This is the coolest part, okay? So let's go back here to our processor. Actually, let me stop my source here, just so we don't get out of control here. So stop that. So let's go back to our processor, and let's add something else too, because what we have here, we have a function that's taking a subscriber and converting to another subscriber. What if we want to add on to this? So if we take a function, and we'll take our function, we'll accept a flux of subscribers, all right? And then we produce a flux of subscribers, and we'll call this reverse it. Reverse it. So cool, right? Okay, so we will now we do a return subscriber flux, and we'll take that and map that to, and we'll just grab this whole thing right here. And drop that in, except we want something a little better than this, right? That's a little lame. We were already uppercasing it. So I'll just create a private string reverse, and we'll accept a string of s, right? And we'll return string builder dot, actually s, I need to create a new string builder. Again, getting ahead of myself. We'll reverse that and return the string. And then instead of uppercasing here, we'll just do a not reverse it. Reverse that. And we'll reverse this as well. Look at that. Okay, so the cool thing is we now have a function that takes a subscriber and returns a subscriber. We also have a function that takes a flux of subscribers and returns another flux. And then all we have to do here is chain them. So we just go to our application properties, and we just pipe it, reverse it. And it doesn't matter because Spring Cloud Stream is being retooled, even as we speak, entirely reactive underneath. It's very easy to go from a non-blocking to a blocking model. Completely crazy to go the other way around, right? But it's easy to go from non-blocking to blocking, so we can do this kind of stuff automagically. It's so cool. So I'm going to restart this. And then once this starts, we'll go and we'll restart our source. I'm going crazy here. I started them both at the same time. What could possibly go wrong, right? So our source is up and running. So now if we take a look at this is our processor, right? So let me see if I can bring that back into presentation mode. Look at that. So now we've got them uppercased and reversed, which is kind of nice. Actually, that is our sink. So I'm showing at the end in case as well. So, and here is our processor. And there we, no, that's our source, excuse me. There's our, well, see, it's not going to do this unless I go out of presentation mode again. And that's it. IntelliJ. Okay, so we'll go back to our processor and out of full screen. I'll have to restart this just so I can bring this up. And there you go. Everything's working fine. So that is kind of a look ahead at where we are, where we're going, and how we're going to get there. Now, just to wrap things up on a neat note here. So I've covered all this stuff except the end, turning it up to 11, because here's the crux of it. We have all of the pieces in place except for that reactive rabbit binder or the reactive Kafka binder. That's the good news. The bad news is I'm the one responsible for writing that binder. So I'm a little behind on that. So that should be coming out here soon. I'm estimating in the next 30 to 60 days. So we've got all the pieces ready. It's fully reactive except for that middle pipeline, which is still pushing from Rabbit in this case today. But that will be solved very soon, and then it will be fully reactive end-to-end, which is super, super exciting for maximum scalability. So with that in mind, here are some resources you might find useful. That's the GitHub repository, which all the code that I showed you today, and I'll be adding to that as you go. So if you want to keep up on that, start it, watch it. And then Spring Cloud Stream Project Reactor pages. And here's the best way to reach me, emails, or even better yet, I should say that's the best way to reach me, is on Twitter. So if you have any questions, comments, or feedback, just let me know. Happy to hear them, and see you around today. Thanks for coming to JavaDay.